So, from the lens in the living room, 3D. Surely it's just a fad, isn't it? For God's sake, I remember going to the cinema when I was a kid, and I saw this Muppets one, absolutely brilliant. Sat in there, the old glasses on, and this thing came out, like almost punched you in the face. It was absolutely brilliant. And in fact, I saw it at Disney in the States, and they actually had little water jets as well. So when they splashed you with water, you saw the water coming out and even squirted you in the face. Absolutely fantastic. Second, I was outside, more interested in ice cream. So, is it a fad? Whoa, it's an interesting one, isn't it? What do they expect us to do now? They expect us to buy a really expensive television set, and I just bought one. I've just upgraded from my cathode ray tube to my flat screen, so how's that going to work? And then they expect me to wear glasses as well. Not only cheap glasses, but really expensive glasses. Well, surely I'm not going to do that as well. I mean, that sounds a bit of a fad as well. What else do they want me to do? Well, they want me to buy new machinery, and then they want me to go out and buy specific 3D content. So this surely has got to be a fad. Well, maybe not this time. Maybe things are slightly different this time. And I want to explore the reasons why I think that is. What do we actually need to make 3D sustainable? Well, as in all of these cases, the first thing is infrastructure. When I went out to Disneyland to have a look at that, I can't tell you how many years ago, but I was only about that big. The infrastructure was simple. It was a theme park and a cinema, and that was it. Clearly the infrastructure has changed massively now. The devices, well, it was in a cinema, so it was just a cinema. The device was a projector and some glasses. The content was one piece of content. If you went to a different theme park, sometimes you could find another piece of content, but the content was very, very sparse. And commercial opportunity. Well, the commercial opportunity there was not specifically about getting revenue for that one experience. It was part of a massive experience in a whole theme park for which basically it was a sum of the parts. So really, what are we going to do about making sure that we do have an infrastructure that's sustainable, devices, content, and commercial opportunity? Well, let's have a look at the 3D formats first, because I think it's really important to actually understand what we mean about 3D, especially as we see it today. So when we start with a brief history of this, it's been around for a long time. The first stereo animation was in 1855, would you believe, when they started having a look at the idea of stereoscopic vision. And by the turn of the century, we also had 3D photographs being created, and you might actually see these in some museums. And then through the 1950s up through to the 1970s, when these started to hit the cinema in reasonably big numbers, and they wowed audiences, but again, it was only a cinema experience. But the idea had to wait until basically technology enabled us to bring this to people in devices that they understand. And it takes a long time, so if you have a look, the TV was invented in the 1930s, but it didn't actually start to boom in terms of install base until the 1970s, and from there onwards. 3D TV will be from the 1950s, basically, but it'll only start to install itself really from now. Mobile phones, 1970s, I had one of those massive, great big things, but didn't become a major part of people's lives until 1995. When we start to forget how quickly these things have actually gone from niche to mass market, and that's vital that we keep that in our minds. The internet, invented in the 1980s, but it's only since 2005, so maybe 5 years until it's a part of everybody's life on multiple devices. Thinking about 3D, we have to kind of work out, well, actually, how does 3D work? Well, first thing we have to understand is how our eyes work. So understanding parallax is absolutely crucial. So in the negative parallax, the objects, if you have a look at that top graphic, you see the two eyes, you see the specks, see the dark one on the left, okay, you're looking through that. What's being projected are two images. So you've got the dark one on the right and you've got the light one on the left, okay. So objects in front of the screen, will appear in front of it when you focus through, okay, you can see that. So the black through the area of focus, through the black one, and what's happening is the image is starting to stand out. So that's negative parallax. Zero parallax is obviously when you're actually focusing, the two dots are together, as you can see, and that will make it appear actually on the screen. On the positive parallax, it's exactly the same thing as the top one, but the reverse. So you see the black lens, the black image is on the left, and as you're looking through, you start to separate your eyes out that way, and the product seems to be behind the screen. So that's fundamentally how 3D works. Then we can start to have a look at how we play with the image using that philosophy. So with two cameras set up correctly, the 3D image can be modified to give the image more depth or position it either nearer or further away. It won't actually get bigger in size, but it's about the relative position of the product. So with the image shown here, shot with two cameras, there are two adjustments that can be made. Now, interaxial distance, remember that term because you'll be seeing that quite a lot over the next few slides, or toe-in angle. So a standard 3D shot. Now the camera's placed at 65mm apart. Now that's roughly the distance between your eyeballs. So that's really important because we want to get into a situation where the cameras are seeing what you see, simply because we all see 3D unless we've only got one eye or there are other couple of situations that will stop us seeing in 3D. So that's the nominal 65mm, parallel to one another in this particular case, and that produces a reasonable 3D image. It's pretty much a natural image to what you would expect. That's got a pleasing amount of perceived depth, and the whole scene is in front of the screen plane, as you can see. That's the grey line at the back. Now, if you increase that interaxial distance, in other words, you move the cameras apart, then you get something very, very different. When the distance between the two cameras, commonly referred as the interaxial distance, or IAD, is increased, the perceived depth increases and the distance between objects and the scene appear to increase. Now, you have to be careful with this because care should be taken not to increase the IAD too much. Close objects will appear closer but won't get any larger, and that's not natural for us. We don't see things that way. And the 3D illusion will break if the interaction distance gets too large, and that becomes difficult when you start thinking about how you actually put your cameras together. Now, the other thing is called toe-in. So basically, if you've got the two cameras are not quite parallel, but you start to actually angle them in, we get a different effect. So when the angle between the two cameras is altered to point them slightly towards each other, commonly referred to as toe-in, the perceived 3D image goes further into the distance, even though the various objects appear to be separated by the same distance. So they just both get further back. So again, care should be taken not to push the 3D scene too back, because actually you can squint because you're straining to see it. You also get keystone errors, which is the kind of error that you would get when you've got a projector on the desk and you're pointing up at the screen. You can sort that out in post-production, but it's something that you want to try and avoid. So actually, how do we get these cameras to get them in a situation where the interaction distance is pretty much the same as the 65mm? Well, parallel rig, clearly side by side. Opposing rig, where you've got really big cameras, and what you do is you have a mirror in the middle, and that's the bit that keeps the distance exactly the same. And then the most common one, which is the mirror rig. So looking at the pros and cons of the rigs that we have, because this is quite interesting for us. Side by side is great because you get full light into the camera. And it's very, very good for handheld situations, very, very good for small cameras as well, and it's great also for crane and boom shots as well. The opposing system, not really used anymore. It was great when you were having some very, very big cameras, but the rigs were just too cumbersome to make, so you'd have to have a huge dolly to carry the stuff in. So really it comes down to the mirror rigs, where basically you have a transparent mirror, and you're forcing them in at 45 degrees. And that way you can alter them again to make sure that you've got your 65mm or thereabouts. That's great because you can use some really, really big and sensitive film cameras. The downside is that you only get 50% of the light into each camera. But again, we can sort that stuff out in the processing side. So, once we've actually created the digital image, we shot it, how do we view it? Well, these are the three. When I was asking the guys at the 3D Tech Centre in the States, what three should I focus on? He said, well, why end at 3? There are scores and scores and scores of different types of 3D standards, which is a real problem for us. But the three that I've gone through here, I think, are the most widely used. The anaglyph glasses, obviously, that you will remember from years and years and years ago, where we used 2 colour filters. The polarised ones, where we either have linear polarisation or circular, I'll go into that in a sec, and the new ones, which are the shuttered glasses. So this is basically how it works, okay? The anaglyph is obviously the oldest method of 3D. And there are several different types, but they all use 2 opposite colours. The most common one that we've got here is a red filter for the left eye and cyan for the right eye. So what we do is we have the image, which is recorded and shot with a left eye and a right eye view. We then apply a filter on the 2. We combine them, so we are now showing both shots, both with filters. Then we filter out through the glasses one of those shots or the other one, so each eye only gets one scene. The brain puts those 2 scenes together and we have 3D. So the advantage of that, it was very, very easy to do. It was very, very cheap. It was only pence for the glasses. Disadvantages was, if those 2 colours aren't exactly the same, you get inefficiencies. So the chances of you having the right colour filter with the right filter that was actually produced on the film, then you're not going to get the effect that you want. So colours were very, very difficult to perform as well. So that's a system that basically we certainly wouldn't use anymore. The polarisation issues, they both work in exactly the same way. Basically, you're polarising an issue. For those old enough, you'll remember the Foster Grants advert where they just shot, you saw this wonderful swimming pool with light showing off it, and you put your Foster glasses on and suddenly there was a woman swimming. Same theory. So you're polarising the issue, and what you do in the top one is you have horizontal polarising and vertical polarisation, and in the bottom you have circular polarisation, so it's going either clockwise or anti-clockwise. And again, the same thing, so regardless of whether it's horizontal or whether it's circular, same process. 2 images, both apply a filter, put them together. Your glasses, again, are either linear or circular, and then you get the image. The only trouble with the linear polarisation is that if you start to move your head, clearly you're not then either vertical against the picture. So that gave some issues of being very, very sensitive to how you actually view, and the circular ones are much, much better. Now, the projector at the bottom is the new Sony 4K projector. Just been put into Apollo theatres. It's got some large attachment in the States as well. The projector, the large projector you're seeing here is a 2K projector. There are 2 makes, there's Barco and there's Christie that do the 2Ks, and the new ones are 4. The benefit of that is that what you do is you have 2 screens and you have a polarising filter on the front of it. We split the output from the 4K into 2 2K projections, one on the left-hand side, one on the right-hand side, and then you